Welcome back everyone to the Hello World Guide. This is another episode of the C++ Raycasting game series, and in this video we are going to finally completely handle the texture coordinate stuff that we kind of left out in the last video. So for that I'm going to switch to our project directory. Inside of this I'm going to open up render.pp, and with this opened up I'm going to go here and you can see that we implemented the basic texture stuff in the last video, like loading the texture and actually applying it to our sprite and then drawing that sprite with the correct scale and everything. So if I go here and run make, for example, so you can see that I've got make here, and if I move around you can see that there are these walls that I've got here, and while our texture is being applied, it's of course the texture coordinates are not correct, for which reason it does not look like the actual texture at all. So we need to now fix this problem. So in order to fix this, I'm going to go here and inside of where we are drawing our 3D view, you can see that in here we are setting our texture scale and our texture position and everything correctly. So the thing we'll need to do is we'll need to also set the texture coordinates. In order to set that, we just use the set texture rect function here, which requires us to pass it an sf : int rect, and with that let's create that. So we have got our interact here, and for the actual values let's pass in 0 and 0 for the actual coordinate where it's going to be located. It's going to be starting from the top left corner of the texture, and we are going to make it cover exactly like one column width for on x, and on the y it's going to cover the whole. So by default this is like wall texture dot get size dot x, and this is like wall texture dot get size dot y. So this is what it is like by default. This is the size of it by default, and in order to change this, we'll need to basically divide this so that it's equal to one column width in our basically if we take into account our wall. So we can do it quite easily by taking this and dividing it by our map dot get cell size. So this should work. However, if I actually run this, what you should see is that we get a blank screen and nothing on it. That's because our scaling is now become incorrect, so we need to remove this division and just set it equal to column width, and yeah, and you can see that it now works. We have got a working texture view here, and you can see that kind of it's not really a texture view, but it's only displaying like the top left corner of the texture, but it is working and we are setting that correctly. So all that we need to do now is make sure that the starting position of our texture is also set correctly. So in order to do that, let's go here, and in order to calculate the starting position, if I am going to calculate it as such, so if, we are going to call this texture x, and in order to calculate that we are going to take our race y position which we hit, and then we are going to subtract from it our wall texture dot get size dot x, and we are going to multiply to this. So like we are doing the multiplication first, of course, according to like the operator precedence. So we first of all take the floor of our race hit position dot y minus the actual size of the texture, and remember whether we take x or y here, it does not make a difference since our texture is a scalar. So then we go ahead and multiply that by the texture size, and we take the floor of this here, not rounded, take the floor, then we multiply that by our texture size, and then we subtract the value from the ray.hit position.y, and this gives us the correct position that we need to use for our texture's x coordinate. So now let's go here and say texture x here like that, and now let's run this, and yeah, you can now see that our texture of rocks, whatever we had, is kind of working. Stone wall is working, but it is only working on the vertical walls, and on these horizontal walls it's not working at all. It's completely incorrect. So yeah, you can see that it is only working on the walls that are facing vertically. So all we need to do is we need to just modify our calculation a bit for vertical walls. So we'll define this for horizontal walls. So we'll define the texture x variable first, like that, and then we'll go ahead and check if texture x, not texture x, we are going to check if our ray dot is hit vertical. So if the hit is vertical, we are going to calculate it like this, and of course we are going to assign this to texture x actually, and if that's not the case, then we are going to do a different calculation. So I'm going to basically, let me just paste that here for now, but I will change it later. So let me go here and say texture x is equal to like that. So yeah, we have got that, and if I just run this, it should still be giving us exact same result. It's not working on these walls, and it is working on the other ones. So all we need to modify in here is that we need to remove the actual subtraction in the beginning. We need to change this to use ray.hitPosition.x and not ray.hitPosition.y, like you can see here I'm using x here. And we are going to change this to use ceiling instead of floor for actually rounding off, and we are going to subtract ray.hitPosition.x from this total calculation. And now if I run this, you should see that we have a texture raycaster working, and it's working pretty much correctly for both our x-axis and y-axis and horizontal and vertical walls. And yeah, it's quite awesome. So we are getting like textured walls in our scene. Anyways guys, this is pretty much it for this video. I'll see you in the next one, in which we'll start to add more stuff to our game. So stay tuned for that. Make sure to like and subscribe as well, and share this video with other people.